Hi, my name is Nure. I'm a rising junior at Mountain View High School. I started with my starter project, which was the digital trumpet. Based on which button you press, the piezo buzzer makes a sound with a different note. I chose that starter project because I wanted an introduction to circuits with an Arduino, as well as a fun end goal like making different notes. So for my main project, I made the smart garden. I used the Arduino MKR1000 as well as the MIT App Inventor to make an app on my phone that displays the temperature, moisture, and light data of a plant. I chose this as my project because I enjoy gardening and also wanted to learn how to send data onto my phone. How does this project work? Well, let's start with the sensors. So the temperature sensor is the sensor with the 3 pins. So it has a diode that depends on the temperature, and I used a formula that converts the voltage received into the temperature in degrees Fahrenheit. The moisture sensor has 2 probes, and it measures the resistance of the soil between the probes. And the light sensor is the sensor that varies its resistance depending on the light. So if there's more light, there's less resistance. Moving on to the app, I used MIT App Inventor, and to include graphs in the MIT App Inventor, like the one shown up there, I used ThinkSpeak, which is an IoT platform, and it only required a few lines of code, and then the ThinkSpeak API automatically created a graph for each sensor. Additionally, I wanted to print out the individual data values, and for this I needed to create a web server. A server is a computer device or program that provides functionality for other devices called clients. And in my case, I wanted my client, the MIT App Inventor, to allow access to connect to the web server of my Arduino. For this code, I printed out the 3 sensor value data so that the MIT App Inventor could connect and display this data. The most challenging part of this project was creating the code for the web server, because a lot of times it didn't work and I had to look at sample code to find out what was wrong, in addition to using print statements. Also, after I got it working, I needed to figure out how to connect it to the MIT App Inventor, and there were no clear tutorials for this, so I had to look at many YouTube videos, and in the end I figured out that I had to use the web component in MIT App Inventor so that I could view the web server data. I want to later add a modification where I add a water pump so that when the moisture level is down, it automatically adds water to the plant. I had 2 main takeaways from my experience at BlueStamp. Number 1, I learned that I can do this, because I went into this project not really knowing how to start, but then I saw that I was quickly making progress. Takeaway number 2, I learned to take advantage, because this is for me. A lot of situations we forget that the whole purpose of it is to benefit ourselves. BlueStamp, however, reminded me of this purpose. So I'm really grateful for this experience, and will take with me the confidence and insight it gave me to move forward. Thank you. Any questions? Yeah.
So does your project constantly monitor the like the temperature and the moisture, and it's storing that on the server?
Yeah, so like the individual data values, like temperature, moisture, and light, should update every second,
Every second?
but the graph updates every 15 seconds.
Okay.
Yeah.
Oh, go ahead.
Oh.
And did you have like test it with putting water and then sun and that?
Yeah, I tested the soil moisture sensor by adding water, or just putting your hand on it works too.
Okay.
And then for the light, I could just cover it with my hand and see if it makes a difference.
Okay.
Would you say that you would actually, what are your future plans for this? Would you implement this in your own garden if you have it at home?
Yeah, I would actually want to see if I could implement it in my own garden, just for one plant. and hopefully the water pump will turn out good too, so that'll be actually really useful.